Hi, now that we have gone through the architecture lectures and the labs, let's revisit the case studies and let's look at the different solutions that as an architect you can propose. So the first one, TerramEarth, which is about a manufacturing company. Uh, they are into mining and agriculture industries. 80% of their business is from mining and 20% from agriculture. They currently have over 500 dealers and service centers in 100 countries. Their mission is to build products that make their customers more productive. So if you remember the background and sort of current state and the business and technical requirements, mining based, they have lots and lots of data that they collect, almost 9 terabyte per day. And they have around 200,000 vehicles which are connected through cellular networks, but a lot of vehicles. This is 20 million vehicles which have no connectivity. They take the data, they upload it to FTP server and then they do the ETL and push it into data warehouse. Um, Data is stored in data warehouse for preemptive stock replacement and reduce unplanned downtime of vehicle by 60%. They ingest the data through Python. Their reporting use case is the data warehouse is based on a Postgres and they have off-the-shelf license to do the reporting. The challenge is aggregated reports are 3 week old. Since data is old, customers are without vehicle for up to 4 weeks. Business requirement, they want to decrease the unplanned vehicle downtime to less than 1 week from 4 week. They want to increase their footprint, marketplace, to be able to innovate faster and give more insights about their data to their retailers. Technical requirement, expand beyond a single data center to decrease latency to American Midwest and East Coast, create a backup strategy, increase security, improve data in the data warehouse, use customer and equipment data to anticipate customer needs. Their executive statement is they they want to build better vehicles for lower cost than the competitors. However, the new products with different approaches, they are coming up in the market pretty fast, and their goal is to build their skills while addressing immediate market needs through incremental innovations. So if you look at these problem statements and a possible, you know, future state solution. Now these solutions might not be in the exam as is sort of thing. And a lot of times, a lot of questions are tweaking the requirement and what if sort of scenarios. So you just really need to be on top of this. But these solutions are sort of a guideline, how you would approach this sort of problem. So in their example, it's all about the data warehouse. They want to do a massive reporting. They want to do fast reporting. So for database, you would possibly look at using BigQuery for data warehouse and advanced analytics because their data is based on it's basically collected from 22 hours of operations and daily per second. So you will have a timestamp partitioned data inside the BigQuery. Data processing, they primarily use Python-based program to migrate the data. You could potentially use Cloud Data Flow for serverless ETL data flow, and which can process batch as well as stream data because they do have around 200,000 vehicles which are connected through cellular networks. ML engine or auto ML tables to forecast the anticipated stock needs because one of the things they want to solve is how to better serve their customers, and there's a delay of 4 weeks. So based on the data, if they can anticipate stock need, that will help them serve their customer faster. Vehicles cellular connected, so the vehicles, 200,000 vehicles which are cellular connected, they can use cloud IoT core and transmit the data to PubSub straight away. So they have the data available immediately, and that can help them decrease the 4 week lag to 1 week. In terms of how data is exported, because they are using a port to download the data and the same time using the same port for servicing. So they can use Cloud IoT Core, and then from the IoT device, they can push the data to Cloud PubSub and use Cloud Data Flow as a serverless ETL component to push the data to cloud storage. Message management, they can use cloud storage for storing all of that data. Data flow runner job to get the batch data. Data visualization, because they have problems with reporting. It's a off the shelf application which is limited to licensing based on the server configuration, sort of old ways of doing things, and they are limited in how many analysts can run the daily report. So they can use Data Studio, which can directly connect to BigQuery, and it will allow company-wide analysis. So they won't be limited in terms of numbers of people who know the tech stack and the number of people who can run concurrent queries and all of that. BigQuery partitioning by timestamp will allow faster queries on last 30 days because it's all about servicing the customer, anticipating their sort of the demand for and also projecting if any vehicle issues or anything and having a quick turnaround time. So I hope this gives you a sort of a guideline that how you can approach this problem. Now let's look at the other solution. The next case study is about Mountkirk Games. Mountkirk Games makes online session-based multiplayer games for mobile platforms. They build all of their games using some server-side integration. Historically, they have used cloud providers to lease physical servers. Due to the unexpected popularity of some of their games, they have had problems scaling their global audience, application servers, MySQL database, and analytical tools. Their current model is to write game statistics to files and send them through an ETL tool that loads them into a centralized MySQL database for reporting. Now, let's look at the possible solution for this particular case study. So, reading the background again, online session-based multiplayer games maker for mobile platform. Use case is they want to build a new game, which is expected to be very popular. They want to deploy games backend on compute engine to capture streaming metrics and run intensive analytics. They want to auto scale server environment and integrate with managed NoSQL DB. Current state games built using server-side integration. They use IIS and they have other application server, MySQL DB and analytical tools. As part of application, they write game statistics to files. They use ETL tools to send data to centralized MySQL database for reporting. So the main challenges is scaling. Scaling for global audience, auto scaling of their reporting and application servers. The business requirement is increasing to a global footprint, improve uptime, downtime, because downtime is loss of players, increase efficiency of the cloud resource they use, and reduce latency to all customers. So it's all about making it available to the global audience without compromising efficiency and latency. Technical requirements for the backend platform: dynamically scale up or down, connect to a transactional database service to manage user profile and game state, so which they are pointing towards having a NoSQL kind of database, store game activity in a time series database. As the system scale, ensure that data is not lost due to processing backlogs. So there has to be a proper rewrite consistency. Requirement for analytics platform, which dynamically scales up and down, process incoming data on the fly directly from the game servers, process data that arrives late because of slow mobile networks, allow queries to access at least 10 terabyte of historical data. So huge data warehousing solution, which can connect directly to your edge networks, as well as it can it can process incoming data on the fly. In terms of the executive statement, Their last successful game did not scale well. Uh, and what they are looking at is primarily to have more KPIs to evaluate the speed and stability of the game, as well as the other metrics that provide deeper insight into usage pattern so they can adapt the game to target user. Additionally, I mean, which is they've been saying all along, is that their current tech stack does not scale, and they want to replace MySQL and move to an environment that provides auto scaling and low latency load balancing and frees them up from managing physical servers. So if you look at a possible future state solution, is of course they because as they have said they want to use some sort of virtual machine, so they can use engines as suggested with managed instance groups. So with HTTPS load balancing with auto scaling. So because they have talked about deploy games backend on compute engines. Now, as a, as a GCP architect, what we can help with is that this compute engine will be based on a managed instance group. So it can auto scale because it's templatized. It can auto scale depending upon the demand. Cloud operations logging with custom metrics to scale up and down. So based on the cloud operations logging, we can have custom metrics, and depending upon that matrix and using the managed instance group, it can scale up or down. Cloud data store for transactional game state. All of the mobile game state, user profile and everything, they can use cloud data store for transactional game state, which is basically as a next generation. It's called Firestore. So, and we have talked about Firestore runs in two mode, native mode and data store mode. So they can use the native mode. Cloud PubSub for buffering of live and late data. Cloud storage for data uploads, cloud data flow for bulk and stream processing. And they can, of course, they can use BigQuery for storage and analytics. This can also contain the 10 terabytes of historical data. Now, most of these services, if you look at it, they are serverless. They are managed services. So it takes away the operational part of it, and it also takes away sort of them not expending a lot of time in managing servers. This is a it's a sample Google um, example for a mobile gaming analytics platform. So this is the sort of architecture you can look at it. So in this architecture, uh, from any mobile gaming platform, you receive real-time events or you receive batch load. If you receive real-time events, you can use App Engine, which will push the data to PubSub. App Engine because it's a completely managed platform and it auto scales. So and it's deployed globally. It can receive data, send it to PubSub, and then Cloud Data Flow as in a streaming pipeline will pick it up from PubSub and push it to BigQuery. In the batch load, you will upload the data to storage. Again, Cloud Data Flow using the same logic because Cloud Data Flow provides a unified uh, programming interface for streaming as well as batch. So it can process and push all of that data to BigQuery. And then at the same time, when you are getting the batch data, you can basically use cloud data prep for visual data preparation. So sort of a lot of data profiling and all that stuff, what sort of data it is, and you can push that to Cloud BigQuery, which can be used by Google Data Studio or Looker, Tableau, partner BI tools, Google Sheets, or by the co-workers which can directly look into Cloud BigQuery uh, for insights. So that's the sort of sample mobile gaming analytics uh, platform. And depending upon the question, what's the different tweak or something, that's the sort of pattern you can look at it. Now let's look at the third use case. So third and last one is Dress for Win. So Dress for Win is a web-based company that helps their users organize and manage their personal wardrobe using a web app and mobile application. The company also cultivates an active social network that connects their users with designers and retailers. They monetize their service through advertising, e-commerce, referrals, and a freemium app model. The application has grown from a few servers in the founder's garage to several hundred servers and appliances in a co-located data center. However, the capacity of their infrastructure is not insufficient for the application's rapid growth. Because of this growth and the company's desire to innovate, Just for Win is committing to a full migration to a public cloud. So it's a case of cloud migration. It's a case of managing the service and having a scaling solution which which grows beyond the capacity of lots of servers in sort of, which has grown from a garage kind of setup. So let's look at this and the possible solutions in detail. So in terms of the background, again, web-based wardrobe management company, services provider using web and mobile applications, active social network. Business monetizes their services through advertising, e-commerce, referral, and a freemium app model, grown from Founders Garage to several hundred servers and appliances in a co-located data center. The use case statement is they want to do full migration to public cloud, but as part of first stage phase, they're looking at migrating dev and test environment, and then build disaster recovery sites. And then they're not really sure whether it should be a lift and shift or refactoring, and it's the core of architect's job is based on the learnings from first phase migration, you suggest lift or shift refactoring or sort of 6R kind of solution. Current state, a single data center, all servers run Ubuntu, databases MySQL, compute 40 web application servers providing microservices base. So this is a big opportunity to improve. Tony Apache Hadoop Spark servers, big opportunity to improve. RabbitMQ servers for messaging, this is a big another big opportunity to improve. And then they have a lot of other miscellaneous servers, which are Jenkins, Bastion host, and all of that. For storage solution, ISC's SI for VM host, fiber channel, NAS. Now all of these are they're doing it because it's sort of a homegrown network and storage solution. Challenges: capacity of the infrastructure is insufficient. So we need to look at some scaling solution and some managed server solution. Impediments to innovate faster and high operational cost. Business requirements: build a reliable and reproducible environment with scaled parity of production. Improve security by defining and adhering to a set of security and IAM sort of best practices. Improve business agility, speed of innovation through rapid provisioning of new resources. Analyze and optimize architecture for performance in the cloud. Technical requirements: easily create non-production environment in the cloud. It's all about CI/CD. Implement an automation framework. Implement a continuous deployment process. Support failover of production environment, which is all to infrastructure as a code, application deployment as a code. Encrypt data on the wire and at rest, and support multiple private connections between the production data center and the cloud environment. Their executive statement is the investors are concerned about their ability to scale and contain cost with the existing infrastructure. They are also concerned that a competitor could use a public cloud platform to offset their upfront investment and free them to focus on developing better features. Their traffic patterns are highest in the morning and weekend evenings. During other times, 80% of capacity is sitting idle. So looking at some solution which auto scales and it automatically shuts down when the traffic is not high, so that is cheaper for them. their capital expenditure is exceeding their quarterly projections. So migrating to the cloud will likely cause an initial increase in spending, but we expect to fully transition before the next hardware refresh. So most of the hardware solution we need to solve in terms of managed services or serverless solutions, their total cost of ownership over the next 5 years for a public cloud strategy achieves a cost reduction between 30 to 50% over the current model. Now, if you look at the, you know, each and every configuration as part of their current state, and we try to map it one to one because it's more about a complete migration to the cloud kind of solution. And that's very important when you're looking at a use case where you need to fully migrate the entire solution. So it's about you need to look at each and every stack, try to migrate it, which is a lot of times lift and shift, or in fact refactor depending upon the technology. And then you look at the commonalities where you can combine some of the features into one or collapse certain sort of functionalities. In this particular example, if you look at databases, uh, MySQL, because they're spending a lot of money uh, on the operation side of it, so we can use Cloud SQL as a replacement for MySQL. And then they're also spending a lot of time on RabbitMQ server. They have 3 RabbitMQ servers. Now, Cloud Memory Store, which is, it fully supports open source Redis. So there's no reason we cannot suggest using Cloud Memory Store for Redis because it will again automatically scale and will take care of the load. In terms of the 40 web applications, now this is it's a very typical monolithic kind of example where you used to have load balancer, application server, and the backend databases. Now, those application servers used to host lots and lots of web applications, and it's a perfect use case for Kubernetes and the container-based applications. So use Kubernetes and the containers for microservices deployment, App Engine for application layer auto scaling, load balancer for high availability traffic routing. So move that entire stack from monolithic world to the GCP world. They have around 20 Hadoop servers. So if you have ever worked with the Hadoop servers, you know that managing Hadoop servers is very cumbersome, and it requires a lot of skills to actually stitch together each and every service. So use Cloud Dataproc for Hadoop and Spark workloads. If HDFS connect to cloud storage, if HBase connect to Cloud Bigtable. And you can use Cloud Data Flow for stream and batch processing. And then BigQuery for real-time trending and analytics, which is very it's very standard from GCP for big data kind of use cases. RabbitMQ servers for messaging, social notification. Use PubSub for messaging and social notification, and use Cloud Functions for event triggers. In terms of the other network and Jenkins-based solution, so use Cloud VPN, customer supplied encryption keys, firewall rules, compute region lift and shift to VMs running on GCE. And for Jenkins app, you can use Cloud Launcher for Jenkins app, which is you can either containerize it or you can put it on a VM. In terms of storage appliances, use cloud storage for backups, cloud monitoring for logs, image storage, could go in image repository as well, and multi-regional for disaster recovery. So it's this you can literally find one-to-one mapping for each one of the technical stack because it is primarily a cloud migration kind of use case. Now the other thing was one of the technical requirement was the automation part of it, which spells out CI/CD DevOps. So use CI/CD solution for infrastructure as code and application deployment. For example, use Terraform for infrastructure as code, use Cloud Build Container Registry for application deployment, Jenkins on VM or containerized deployment. So this is the sort of the possible proposed solution. I hope this was useful, and I would like to reiterate this. Please spend a significant amount of time going through these case studies, because in my case, it saved me almost 30 minutes of time. Because if you know the case study very well and you sort of memorize most of its artifacts, even if there's a tweak in the question, even if it's trying to talk about different scenarios, you would be able to relate and suggest appropriate products. And also, when you are reading the question, be mindful of the specific keywords, the specific words. Read between the lines sometimes, because when it technology solutions, there are always multiple options to solve a problem, but there's always somewhere something descriptive in the problem statement which will point you towards one specific solution, unless it's a multi-choice question, but always keep an eye out for that. Let's look at the solution of the two new case studies that's been added. EHR Healthcare, which is a leading provider of electronic health record software to the medical industry. It's a cloud architecture use case for on-prem to cloud migration and how to scale the environments. Helicopter Racing League. It's a global sports league for competitive helicopter racing, which is a cloud AI ML telemetry and streaming problem. Let's look at EHR Healthcare first in terms of the problem statement. It's a health record software. They provide health record software to the medical industry. Their use case is the business has been growing exponentially year over year, and they need to scale environments, adapt disaster recovery, roll out new capabilities, and they have chosen Google Cloud to replace their current co-location facilities. Current state, they have multiple co-location facilities. There's a lot of web-based applications running on Kubernetes cluster. Data is stored on variety of databases, relational as well as NoSQL. Monitoring is done via open source tools. Their business requirement is that they need a high throughput connectivity and 99.9% availability for all of the customer facing systems to reduce latency and make predictions and generate reports on industry trends based on provider data. The technical requirement is maintain legacy interfaces to ensure insurance providers with connectivity to both on-premise systems. So connectivity to on-premise and cloud is very important. They should be able to dynamically scale and provision new environments. And then they're also looking at managing their massive footprint of container-based environments. So now let's look at a possible, future state solution. So from the infrastructure point of view, it's been called out that they have a lot of co-location facilities. The lease on one of the data centers is about to expire. So they can adopt Google's infrastructure or platform solutions for data centers. They can use global VPC for better connectivity so the traffic stays within Google network. They can use multi-regional replication for DR. They can use hybrid connectivity, which is cloud interconnect, which can give them 99.99% uptime SLA. And then they can use cloud VPN, dedicated interconnect for high performance connection between on-premises and GCP. In terms of applications, they have a lot of web-based applications and they run on a group of Kubernetes cluster. So they can bring all of that under one single pane of glass by using Google's GKE, Kubernetes deployment GKE, cloud and on-premise container-based environments management and integration using Anthos. So they can look at Anthos as a way to manage Kubernetes cluster on premises as well as Kubernetes cluster on the cloud from the same pane of glass. Future they have a lot of API-based integrations with the legacy files and all of that. As a future solution, they can look at Apigee to provide that API gateway and for the proxy management of all of the APIs. For predictions, they can utilize AI platform, which is a unified platform for end-to-end life cycle of machine learning. Data ingestion can be done for streaming using PubSub, Batch, using cloud storage. For processing that data, they can look at Dataflow or Cloud Composer to take it to different sync databases. They have a different flavor of relational as well as non-relational databases. So for MySQL and MS SQL, they can look at Cloud SQL. Redis, they can utilize Cloud Memory Store, which is a managed version of Redis, and Cloud Firestore, which is same as MongoDB, or alternatively, they can also look at using MongoDB as a partner solution, which is well integrated within Google Cloud Console. For monitoring, they can look at cloud monitoring for alerts and notification, charts and dashboards, cloud logging, which can automatically ingest audit and platform logs and manage retention and policies. One of the other requirements they had is they are looking at CD capabilities. So they should be able to spin up a lot of environments with ease and basically proper maintenance. So they can use Terraform for infrastructure as a code, use cloud source repositories for storing the source code, use Cloud Build for deployment and orchestration, and then use Artifact repository for container images. Now these are the possible solutions. So there's, again, depending upon the question, what has been asked in the questions, there could be different choice of tools and everything. So just be very careful in terms of the questions, what the question is trying to explore. I hope this helps. So let's look at Helicopter Racing League. Again, as a background, it's a global sports league for competitive helicopter racing. Their use cases are mainly that the existing AI/ML solution that they have, the managed solutions. So they want to migrate it to a new platform. And the second most important thing is they want to make sure that the content, whether it's real time or recorded, can be delivered very close to the users, mainly in the emerging market. In terms of solutions, a public cloud first company. All of the encoding and transcoding is done in the cloud. The enterprise grade connectivity is provided by the truck mounted mobile data centers. The technical requirement is that they store everything in object storage service right now. And the video encoding and transcoding is done by VMs created for each job. And the race predictions are performed using TensorFlow running on VMs in the current public cloud provider. The business requirement is all about exposing the predictive models, giving better insight into races, which is embedded inside the video, which gives them better fan engagement, and to basically create a merchandising revenue stream. The technical requirements are increase prediction throughput and accuracy, reduce viewer latency, increase transcoding performance, and create real-time analytics of viewer consumption pattern and engagement, and create a data mart to be able to enable processing of large volumes of race data, everything in real time. They want to bring high adrenaline racing to fans all over the world. And the whole idea is to basically engage fans as much as they can through the videos. Let's look at some of the possible solutions. So one of the major ask is about and that happens with most of the media content, is about the transcoding services, and which is pretty complex. A lot of times you have the code base spread out everywhere. Every VM for every job does the transcoding. So what they can look at is use preemptible instances for VM-based encoding solutions, which is much cheaper and you can spin it up. But as a long-term strategy, they should look at containerizing the transcoding solution and manage it using Kubernetes engine. This gives them much better scalability, faster transcoding solutions, and you maintain a single code base. And this way, because it auto scales, they can run lots and lots of transcoding at the same time. TV box telemetry, the combination of App Engine to ingest data and then transmit it using PubSub, use data flow for the real-time streaming ETL work, and then you can push all of that data to BigQuery. You can use Cloud Composer as an orchestrator to orchestrate the ETL work on these video feeds to different things. Then cloud monitoring to have a better visibility into telemetry and get additional insights. Now, one of the other ask was to have a live video, to have a better, so almost negligible latency for live videos. So possible solutions that they can look at is use HA configuration of Cloud VPN for connectivity between mobile data centers and Google Cloud. Use Cloud CDN for delivering content with the speed, efficiency, reliability close to the users. Use cloud storage with multi-regional buckets to serve contents. And then they can look at the PerfKit benchmarker, which is provided as part of Google ecosystem, which gets them visibility into metrics like latency, throughput, and jitter. So once you have set up the multi-regional buckets, Cloud CDN to deliver those contents, you can look at this benchmarker to actually see which region and where, and mostly in the emerging market, what's the latency, and accordingly you can act on it. Google Cloud also offers Network Intelligence Center, where you can get comprehensive and proactive monitoring, troubleshooting, and optimization capabilities in terms of the content delivery. For AI and ML, they can look at AI platform for predictive efficiency, use TensorFlow deep learning VM instances. Then for analytics, one of the requirement is to create a data mart. So use BigQuery as a data mart for processing a large volume of data. You can use Looker for embedded analytics. So on that data with applied AI, you can get the real-time analytics, which can be fed back into the video for better fan engagement. Use BigQuery streaming API and ML solutions to get additional insights for increasing fan engagements. So I hope this helps. Again, the solutions are as good as the requirement, and you have to look at the question that what part of the requirement the question is trying to point towards. There are always multiple solutions, and it has to be, and the clue always lies in the questions. There will be something which filters out some of the options. So you have to be very careful and read the questions very clearly and try to find out those sections of the questions which try to filter out some of the options. So I hope this helps. Thanks.